Which assignments satisfy the formula P0x or P1y in the below unary structure? Even a casual look reveals that S0 satisfies the formula, as S0 gives x the value b, which is in P0m. Also, S1 satisfies the formula as it gives x the value c, and also c is in P0m. Finally, S2 does not satisfy the formula as it gives both x and y the value g, which is neither in P0m nor in P1m. More exactly, let us look at the assignments. The value of S0x is b, and b is in P0m, the interpretation of the predicate symbol P0 in the structure M. So definitely S0 satisfies the disjunction P0x or P1y in M because it satisfies the first disjunct P0x. The value of S1x is c, and c is in P0m just as b above. So again, S0 satisfies the disjunction P0x or P1y in the model M because it satisfies the first disjunct P0x. Finally, S2x is g, and g is not in P0m, so we cannot conclude that S0 satisfies the disjunction in the model M yet. We have to check also S2y, which is again g. But here, likewise, g is not in P1m. So in the end, S0 does not satisfy the disjunction P0x or P1y because it doesn't satisfy either of the disjuncts in M. So the answer is S0 and S1 satisfy the formula in M, but S2 does not. Which assignments satisfy the formula P1y implies left parenthesis P0x implies P1z right parenthesis in the below unary structure? A quick look reveals that S0 and S2 satisfy the implication as both fail to satisfy the hypothesis of the implication, namely P1y. Recall that an implication is true if the hypothesis is false. So we can right away conclude that S0 and S2 satisfy the given formula in this structure. When we then look at S1, it does satisfy the hypothesis P1y. However, it does not satisfy the conclusion. The conclusion is P0x implies P1z. It does not satisfy it because it actually satisfies P0x but not P1z, because the value of z in this assignment, namely element c, is not in the set P1m. So after this quick look, we can conclude that S0 and S2 satisfy the formula and S1 does not. Let us look at it a bit more carefully. The value of S0y is c, and c is not in the interpretation of P1 in M. So certainly S0 does not satisfy the formula P1y in M. But then S0 satisfies the whole implication because it doesn't satisfy the hypothesis. Okay, now let's go to S1. The value of S1y is a. And a is in P1m. So now we cannot conclude that the implication is true because the hypothesis is false. So we look at the conclusion of the implication, which is another implication. P0x implies P1z. The value of S1x is A, and A is in P0M. So in this implication, again, the hypothesis P0x is satisfied by S1. And to conclude whether the implication is true or not, we have to look at the conclusion P1z. Okay, the value of S1z is C, and C is not in P1M, so the final conclusion is false. This means that S1 does not satisfy the implication P0x implies P1z, but it satisfies the hypothesis of the entire implication, namely P1y. So we conclude that S1 does not satisfy the given formula. Finally, let us look at S2. S2y is E, and E is not in the set P1M. So, as has been already mentioned several times, since an implication is true if the hypothesis is false, S2 satisfies the given implication. Which assignments satisfy the formula P1y or left parenthesis P0z and P1x right parenthesis in the below unary structure? If we look at the situation casually, the given formula is a disjunction. An easy way to satisfy it would be to satisfy one of the disjuncts. So, for example, P1y. Well, let's look at the value of y in these assignments. S0 gives y the value c, which is in P1, so S0 definitely satisfies this formula. S1 gives y value e, which is not in P1M, so we can't proceed there. S2 again gives y the value e, so no easy solution there. Let's then look at the second disjunct. It's a conjunction of P0z and P1x. So we have to pay attention both to z and to x. In S0 they are both c, and c is in P0 and P1. But on the other hand, we already concluded that S0 satisfies the formula, so let's move on to S1. Here x is A and z is C. Both A and C are in P1 and P0, so again we get the result that S1 satisfies the formula. Finally, S2, it gives x the value f and also z the value f. Let's look at f. F is in P1, but it's not in P0. So S2 doesn't seem to satisfy this formula. Okay, let's look at it a bit more carefully. The value of S0y is C, and C is in the interpretation P1M of the predicate P1. So S0 satisfies the formula because it satisfies the first disjunct P1y. Now we move to S1. The value of S1y is E, and E is not in the interpretation P1M of the predicate P1. So we go on, we cannot make any conclusion yet. We look at Z. S1Z is C. Well, C is in P0M. So now we go on to look at the second conjunct. If that turns out true, then the whole formula is true. The value of S1x is A, and indeed A is in P1M, as the picture indicates. So S1 satisfies the formula because it satisfies the second disjunct, which is a conjunction, and S1 satisfies both conjuncts. Finally, let us look at S2. S2y is E, and E is not in P1M, so we cannot conclude that S2 satisfies this formula simply on the basis that it satisfies the first disjunct. So we go on to the second disjunct, which is a conjunction. Okay, let's look at the value of Z in S1. It's F. Okay, here we note that F is not in P0M, so S2 does not satisfy the first conjunct of the second disjunct. So S2 does not satisfy the formula itself. Which assignments satisfy the formula XEY and YEZ in the below graph? Well, this formula says that there's an edge between X and Y, and there's an edge between Y and Z. So for each assignment we have to look at the values of X, Y, and Z. In the first assignment S0, the formula asks, is there an edge between 1 and 5? Yes, there is. And an edge between 5 and 1? Yes, there is. So S0 does satisfy this formula. In the second assignment, the formula asks, is there an edge between 1 and 1? No graph has an edge between a vertex and itself, so we can move on to the assignment S2. In S2, the formula asks if there is an edge between 1 and 2 and an edge between 2 and 4. Well, there is no edge between 1 and 2, and neither is there between 2 and 4. So S2 does not seem to satisfy the given formula. Let us look at the situation more carefully. The value of S0x is 1 and S0y is 5. We have an edge between 1 and 5, or as we say, 1EM5, meaning the pair 1, 5 is in the binary relation EM, the interpretation of the binary predicate symbol E in this structure. So S0 satisfies XEY, which is the first conjunct. The value of S0Z is 1, so by symmetry S0 satisfies also YEZ. In graphs, the binary relation is always symmetric. So we conclude that S0 indeed satisfies the given formula. Let's move to S1. S1x is 1 and S1y is 1. But the pair 1, 1 is not in the relation EM, because in no graph is there an edge between a vertex and itself. So S1 does not even satisfy the first conjunct, let alone the whole conjunction. Finally, S2. S2x is 1 and S2y is 2, but the pair 1, 2 is not in this edge relation. There is no edge, no line between the vertices 1 and 2. So again, S2 does not satisfy the formula because it doesn't satisfy even the first conjunct. And we are done. Which assignments satisfy the formula XEY implies XEZ in the below graph? We are looking at an implication. So an easy way to satisfy the implication is to have an assignment which fails to satisfy the hypothesis, which makes the hypothesis false. That is an assignment where there is no edge between X and Y. In assignment S0, X is 1 and Y is 5, and there is an edge between X and Y, so the hypothesis is true. The conclusion is that X z, there's an edge between x and z. X is 1 and z is 2, but there's no edge between 1 and 2. So S0 doesn't satisfy this implication. On the other hand, S1 does satisfy because there's no edge between x and y. They are both 1. There's never an edge between 1 and 1. So the hypothesis of the implication is false, the implication must be true. The same with S2. There is no edge between 1 and 2, so for trivial reasons the implication is true. More formally, the assignment S0 satisfies XEY but not XEZ. So S0 does not satisfy XEY implies XEZ by the truth table of the implication. The assignment S1 fails to satisfy XEY and hence it satisfies the implication. The same happens with S2. Which assignments satisfy the formula Rx or By in the below tile model? The formula asks, is X red or Y blue? In S0, X is 1, which is red, so S0 does satisfy the formula. In S1, X is 2, which is not red, and Y is 1, which is not blue. Finally, in S2, X is 2, which is not red, and Y is 2, which is blue, so S2 satisfies the formula. This is the basic idea. Okay, let's look at it a little bit more formally. Intuitively, the question is, as noticed, quote, is X red or Y blue, unquote. So let us see what the assignments say about X and Y. The assignment S0 says X has value 1, that is S0 X is 1. Well, 1 is red, so S0 does satisfy the given formula. The assignment S1 says X has value 2, which is not red, and Y has value 1, which is not blue, so S1 does not satisfy the formula. Finally, S2 says X has value 2, which is not red, but Y has also value 2, and 2 is blue, so S2 indeed satisfies the formula. And we are done. Give in each case a unary structure and an assignment that satisfies a given formula in the structure. We use the same model in each case. The model has 3 unary predicates, P0, P1, and P2, none of which is a subset of the other. So let us look at possible assignments that would satisfy the given formula. For the first formula, this formula has just one free variable x, so we take an assignment S which gives a variable x a value which definitely is in P0 and is not in P1, and B, the element B of the model, is such an element. It is in P0 as the picture shows, but not in P1 and not in fact in P2, although that's not relevant. The second formula, again there is just one variable x. We are looking for an element which is not in P0 and not in the complement of P1. And F is such an element. F is not in P0M and it is not in the complement of P1 because it is in P1, so it cannot be in the complement. Then the third formula, again just one free variable x. We look at an element of the model which either doesn't satisfy P0, is not in the set P0, or if it is in P0, it has to be either in P1 or P2. Well, this is easy. If we simply take the point F, we let the assignment S map x into the element f, f is not in P0, so the implication is true because the hypothesis is false. Then the fourth formula. This is a disjunction of three formulas. This is extremely easy to satisfy because it's enough to satisfy just any of these. So we can take just any element of P0, any element of the complement of P1, or any element of P2. We take the easy choice. We map x to B. B is in P0. The first disjunct is true, hence the whole formula is true.